Okay, so let's get this done really fast so you can enjoy your free time. Right, so these two is just, let me just see if I can do it. 13 over 9, make sure 13 goes inside. That's pretty much the only thing you have to worry about. Dot dot 40, 4, 36, and you can already tell that's going to be a 4 repeating, right? Um, just make sure that you know that it's going to be 1.4 and make sure the bar notation goes on top of the 4, okay? Because the 4 is the one repeating. 17 divided by 18, 0.0, and I'm going to say it's 9. It's 2, carry the 7, 162, 8 left over, bring down 0, 4, 5, 5 seems like a lot. That's 90, right? Yeah, so let's try 4. 4, 2, 7, 8 left over. Oh, thank God. And you know it's going to be 4 again. So again, very simple here. So this, as a repeating decimal, is this. Again, make sure bar notation is on top of the 4. Okay, so there's a little bit of work here, but now you know how to do it. It should be pretty simple. So first number, x equals 2.61 bar notation. I'm going to multiply that by 100, and likewise the other side by 100. We're going to get change colors here. 100x on this side, and just I'm going to bring it over here. So think about what 261 is, right? It's 616161. So by multiplying by 100, we're going to make it 100 times bigger, and just we're going to shift the decimal. It's a little cheating here, and so we don't have to actually multiply. So it's going to be 261.61 bar notation. 99x equals 261 minus 2 is 259, and these two will cross out. Divide by 99, and you're going to get x equals 259 over 99. I'm going to leave it like that for now because I'm not going to have to subtract, right? So x equals 1.3 bar notation, and this one I'm going to multiply by 10 because there's only one repeating number. So 10x, and again 1.333 looks something like this. Multiply by 10, we're going to shift our decimal 1 over to the right, right? So it's going to be 13.333333 bar notation, sorry. Right, and then that changes to 13 point that. So times 10, this becomes 13.3 bar notation. We can subtract now 9x. These will cross out. 13 minus 1 is 12. And x is going to equal 12 over 9 sometimes. And then let's subtract those two. 259 minus 99 minus 12 over 9. We need to find a common denominator, which is 99. No changes necessary on this side, but here it's times 11 times 11. 12 times 11 is 132. Right? Yeah. So it's 99, and 259 minus 132 is 7 to, it looks like 127. And can you leave it like this, or if you change it to a mixed number? It's going to be 128 over 99. If you change it to a, what do you call it? Mixed number. Now this one I would change to, I want to change it to decimal, so I would definitely change it to a fraction. So 32 over 10 times negative, I need my glasses, okay, much better, times negative 5 over 8, and you can, and then let me bring 1 over 1/4, that is 4 times 1 is 4, 5 over 4, right? So that's 5 over 4, and you can, change the multiplication right now if you like. So it's a negative times a negative times a negative, so I know my answer is going to be a negative. If there's any simplifying that I can do, yeah, quite a few. This guy and this guy, divided by 5 become 1 and 1. Divided by 4 becomes 1. Divided by 8 becomes 2. If I divide 2 by 1, 2 by 2 is 1, and 32 by 2 is 16. I can divide these two, top and bottom, by 4, no, by 2. 10 divided by 2 is 5, 16 divided by 2 is 8. I think I'm done. On the top, 8 times 1 is just 8, and at the bottom, 5 times 1 is just 5. Pero it has to be negative 4, negative 1 and 3/5. Remember, a lot of these questions, most of the questions are multiple choices. Okay, so like in this question here, you could have had A, B, C, and D. So, oops. So this could have been a positive answer, a negative, and a negative. You, just by looking at this, know that it's going to be a negative answer, right? So automatically A would have been garbage, and B would have been garbage. And then you would have just taken a look at C and D, and maybe, and that's, then your choice is really not, what do you call, out of 4, but out of 2. So likewise with this question, so your multiple choice could have been a positive answer and negative, and you know you're adding 2 negative numbers. So right away I know my answer is going to be a negative number, right? And then make your choices. You can eliminate some multiple choices. Multiply some of your multiple choices. So let's change this. 63, 64 over 9 plus, and this is, what do you call, 96 plus 5 is 101, right? Over 12. You could have done this, or you could have just changed. You know what? I'm not gonna confuse you guys. So let me just keep it at this when I change everything to a mixed improper fraction. This is -2, right? Sorry, I've done negative there. Put this in parentheses. Multiplied by, this one was by 4, right? Because it became 32, and then times 4 is 16, 256. This one was times 3, so that's easy, 303. We're going to, so it's going to be negative something 36, and 256 and 303, they're both negatives, but same team, right? So we're just going to add those numbers. It's going to be 559. And you can change that to an, what do you call it, mixed number. I'll let you decide. You can do that. Okay, but if you got that, then you know you're on the right path. Now, there's quite a lot of things in here. So there's a division, another division, and a subtraction. So it's, so if you want to rewrite this right now, you can, so I'll do that. So 4/5 divided by 3/7, right? That's what the numerator said. And then we're going to divide that by 21 over 15. Then minus 1.5, which you can or cannot leave as a decimal. I'm going to change to a fraction, okay, just to see, because it looks like that might help. So let's do these two first. So it's 4/5 times 7 over 3, right? There's no simplifying. Yuck. That's going to be 28 over 15. So 28 over 15, right? So this whole thing here, I might even cross it out, becomes 28 over 15, which we're now going to divide by 21 over 15, right? We're going to take this part. And I'm just automatically going to change it to multiplication, and 15 over 21. Now there's some simplifying, okay? So these two simplify to 1 and 1. 28 and 21, I'm going to divide by 7. That gives me a 4. Divide by 7 gives me a 3. That whole thing is going to be 4 over 3, which I am now going to subtract 15 over 10, right? LCM is going to be something like 30, right? A little bit early. And times 10, which is going to be 40, right on top, times 10. Times 3 over here, and then times 3 over here is going to be 45. It's 40 minus 45. You can, if you like, change it. You don't have to by now. You should be really comfortable, right? So these two problems are exactly the same. So this one and this one. One, really, you can really tell that one is a positive number. You're adding a positive and negative. The other one, you're just going to have to interpret it, but you know that both are the same. So here, well, you know your answer is going to be over 30. There's a positive 40 plus negative 45. Negative, we have more negatives here, right? We got make a lot of zero pairs, and you're going to have some negatives left over. And how many negatives left over? You're going to have 5. Now you can simplify negative 1 over 6. Okay. And we're moving. I explain why square root of 7. And I'm going to do a little cheating here. Well, I can't. Maybe I can. So, what is the square root of 7? Hopefully we'll get a big answer. So that's the square root of 7, and it's not even done yet. So let me just write this: 2.6457. So can I copy this? Can, yes. I don't know why I'm copying that. There you go. But, and again, it goes on and on and on and on, right? So if you actually were to multiply that number, I actually don't know. It's actually going to be either something like this, right? 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, maybe 1, or it could be this. Not gonna really, you know, as far as these two are concerned, if you round, so one of the two is a number very, very, very close to 7, but not 7 yet. But it's irrational because I can't take this number, right? And I can't do that little conversion that we do where I multiply this number and I set x equals to 2.6457531106 dot 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 dot, and I can't multiply this by, what am I going to multiply this by? You know, I don't know what to multiply that, right? This side and this side, because it's, what do you call it? It won't help me, right? And I multiply this by, again, by whatever, 10 billion, quadrillion are here, and then I don't know what, shifting this decimal to the right however many spaces, it's not going to really change, because when I set the other one, right, on top, and I go like this, and if I shift this however many, I can't subtract, and when I subtract this number minus this number, the part that's right of the decimal, it's not going to cancel each other out, right? It's really not going to help me. So I can't change it. I can't express. I'm unable to express this. Can't express it as a rational number. Right? Remember what that is? It's a ratio of two integers. Right? I can't really put this as a ratio of two integers, so that's why it's irrational. Okay. I have to go to work today on Saturday. So, not. 1 second. Here we are. So now this one is an area rectangle. So we know area equals length times width, right? Let's substitute what I know. So I'm going to write 16 over 1/5, but I'm going to change it to a something improper. So that's going to be 5 times 16 is 30, 80. So it's going to be 81 over 5. So I'm just going to go ahead and make my changes. I know the length. I don't know the length, but I know my width. 7 1/4. 4 times 7 is 28. 29 over 4. Right? So think about your equations last year, right? So what do we want to do? So it's a multiplication. So we're going to divide both sides by 29 over 4, right? So think about, I'm going to divide 29 over 4 this side by 29 over 4 and this side by 29 over 4 because we want to isolate the L. So I want my length all by itself, right? So remember what you had to do last year. So somebody told me. So you can write it like this. So first of all, my variable should be here. The 29 over 4L, I'm going to divide that by, you know what, let me just, sorry, let me take a step back. So let me rewrite this. All right, so I'm going to just go 29 over 4L equals 81 over 5. I put my variable on the right side, so no big deal. So it says, right, because we want to use the inverse operation, so I'm going to divide this by 29 over 4, and I'm going to divide this side by 29 over 4, right? So if I do that, what does that mean? It actually means this, right? So if you think about it, it's 29 over 4L, and divided by 29 over 4 means I'm going to multiply by 4 over 29 on the left side. And on the right side is the same thing. It's 81 over 5 divided, but you know, we're changing the division to multiplication times 4 over 29. All right, so this all simplified to 1, leaving what I wanted before, which was L all by itself. Anything I can simplify here? 29 times 3 times 4. Yuck. So on the top I get 432, right? And then at the bottom is 45 goes 4, 145. And I will change this one to an improper only because I don't know what that is. Right? So it's going to be 2 times, which is going to be 290. And 290 is going to be 34 over 145 feet. That's the length of my, that's the length, period. And it sort of makes sense if you look about it, if you look at these two numbers, this is the length, right, and this is the width. That's 7 and 1/4, and this is 2 and 34 over 45. And if you sort of multiply those, that does seem like that it's going to equal to 16. Okay. Estimation. Okay, so what are we doing here? 4 boards. So again, this question was, and I hopefully had some time to think about. Here's my 4 boards. Really matters how you think about this. My 4 boards, and they're 7.5 feet each, right? I'm gonna write 7.75 feet each. And you want to make these little cuts, right? So you're gonna cut them into these size boards. I'm just making this up because it's not accurate, but you want to make these cuts. So let me just here. So I'm gonna cut this first board into 1 4/5, and then make another cut, right? I make another cut, and then again, this is not accurate. Just bear with me here. Make another cut. So if all these boards are separate, I'm gonna have, and I mean, if you look up here, it looks like I'm gonna have this much left over, right? Because I can't make another board. So with one board, how many little pieces I can make? I can make however many, and I'm gonna have some left over. But now, a lot of people, including myself, probably not have thought of that right away. And we put our thought, okay, here I have 4 boards. Let me put them together, right? Now, so let's say you made your cuts, right? You made 1 4/5, and you made 1 4/5, and then let me just make this a little bit longer, right? 1 4/5, and then see how I'm right here right now. So if I'm making my 4th board, I'm gonna take a little bit of my first one and somewhat of my second one. Am I allowed to do that? I mean, am I gonna glue this little piece? I want to glue this little piece with this little piece to make one piece. So it does matter how you interpret this question. It doesn't say if the boards have to be in one piece, or I can, like I said here, should I join them? Personally, I think the question is like this. 4 boards. So let's take the first board. It's 7.5, and I'm gonna see how many 1 4/5 I can make out of that. So this is 15 over 2. time. Let me see. This is 9 over 5, right? 9, yeah, 9 over 5. And then it's going to be 15 over 2 times 9, 5 over 9, sorry. Right? So reciprocal 5 over 9. Simplify, no, 5 times 15. 15 times 5 is some number, 75 over 18. Let's find what that is as a mixed number. I can have 18, 36, 72 4 times, and 3 over 75. So I can make 4 boards here, right? So I can make 4 boards of 1 and 4 fifths. So I can make 1, 2, 3, 4. I have some left over here. And I'm going to change that red. And that's left over. I can't make another board out of that. Right? So what you need to do is figure out, well, I can make 4 is 3 7/5. Hang on a second. You actually can only make 4 boards, and you're going to have 3 75ths, so you can make 4 boards. And you're going to have 3 over 75 of what? Of a feet left over. Right? And this is the part, so the same thing is going to repeat here. You're going to have 3 over 75 left over here. You're going to have 3 over 75 left over. Right? And you have 3 over 75 left over. So in each of these, you can make 1, 2, 3, 4 boards, and I should change colors. 1, 2, 3, 4 boards, and you're gonna have that left over. 1, 2, 3, 4 boards, and again, that should be a very tiny. This should be more accurate. So let me just change this picture again a little bit better for you. Again, we're gonna make 4 boards. So let's make 1, 2, 3, 4 boards. Make a little bigger. So 4 boards. 1, 2, 3, and I'm trying to exaggerate. 4 boards. 1, 2, 3, and then 4 boards. And then I'm gonna, so 1 board, 2 boards, 3 boards, 4 boards. There's that little left over there. 1, 2, 3, 4. Little left over. 1, 2, 3, 4. That little left over. That little left over is 3 over 75, or 3 75 feet, right? So how much left over? Well, it's 375 in each of the big boards times 4. So it's 12 over 75 feet left over. Okay. This is a string question. So I have 19.5, and this is really just a procedural question. Change it to yards. I want to change it to feet. So this is yards. I want yards, and I multiply this by 3 to give me into feet. So I'm gonna make the conversion right away. Why don't I have it? Forget it. Do it the old-fashioned way. 15, 28 to 5. That looks 58.5 feet. This is the second one is already in feet, thankfully. 16.98 feet. Right, and then 1,350 inches. Divide that by 12 to get it into feet. And I will, what do you call it? 1,350. There you go. I can use this. 1,350 divided by 12 is equal to 112.5. So great, 112.5. This is 112.5 feet. All my strings are in feet. Let me add them up. Use a little placeholder here, 0 and a 0. So that's going to be an 8. It's going to be a 19. Carry 1, 10, 17. Carry 1, 7, 8, 9, 14, 247. That's how much you're going to use. How much do we have? 395.76. I'm going to subtract 247.98. Well, a little borrowing from here makes it 14, makes this a 16, which makes this a 15, right? 7, 7, 7, and 4, and 1. That's how much left over I have. Feet. 9. Time for bonus word, and the bonus word is going to be I don't know your bonus word is going to be. Okay, this is that watermelon question. Or that pumpkin question, and let's see what we got here. So it's 315 pounds, 350 watermelon. It's going to grow by 1 5/8, so we can, 8 times 1 is 8, 13 over 8. So our growth is going to go right that much, right? So the watermelon is going to grow quite a lot. So 350, and can we simplify? I can. Divide by 2 is 4, divide by 2 is 175. And then if I multiply across, I get 2,275 over 4. And that's going to give me 568. Uh-oh. Wow, I don't know, it's really going to grow. So it's going to give me 568.75 or 3/4. Right, so imagine you have a watermelon. This whole watermelon is 568 3/4 of a pound. And we're going to use 1, 2, 3, 4, 5, 6, 7. We want to use 4/7 of it to make some type of candy. So we're not going to use the whole thing. So again, we're going to use 4/7 of, and I'm going to keep this as instead of 568 and 3/4, I'm going to go back to the mixed number format. All right, 2,275 over 4. Okay, same thing. So 4/7 of the total size of the watermelon, the new watermelon. That simplifies, thankfully. And we got 2,275 divided by 7, which is, I have no idea. Wow, look at that. Nice, 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 pretty number. We're going to use 325 pounds of the 568 to make candy. I am okay with that. Really am okay. Okay, so I'm going to write your bonus words. I know. I'm thinking of a song, and here's your word. Autumn Leaves. It's a very nice song. You guys should. Played by a lot of people, but played by Miles Davis. It's really, really nice. And we're in autumn, are we? Yes. No. Yes, we are. Okay, so that's your bonus. And it's playing in the background, so actually listen to it. Sorry. Here's a length we want. Length is 2 3/5. All right, and the width is twice that, so we're gonna multiply that by. Let's change it right now. 5 times 2 is 10. 13 over 5, right? So if you multiply, you get 26 over 5. So that's my width, twice the size. And then I want to find the area. So to find the area, we're going to do length times width, right? The area. And I'm going to change, and I already changed that. So this is 13 over 5. So I'll multiply 13 over 5 times 26 over 5. And that's going to give me my area. Simplify? No. 13 times 26. 338 over 25 inches squared, but I can do this. 338 divided by 25, it's going to be 4, 8, 12, 12, 13, but that's going to change to 13, it's going to be 225, 13, 25, and I think it's 13 again. Inches. Watch your notation, inches squared, right? My perimeter, a little bit simpler. My perimeter is going to be all the sides added up, so this is 13 over 5, right? Plus 13 over 5, plus 26 over 5, plus 26 over 5. Just, right, it's all the sides added together, so that's going to be 26 plus 26, which is 52, plus another 26, right? That's going to be 78 over 5. And divided by 5 is going to give me 15, which is 75 3/5 inches. Not squared, just inches because it's squaring. Sets. Okay, this one's pretty easy. I will officially be late today. 921 is just a rational number. Nothing else. Negative 3 to the 6th power is going to be a positive number, right? A positive number. And that's going to be a counting. It's going to be a whole number as well. It's going to be an integer. It's going to belong to that set. And it's going to belong, obviously, to the rational numbers. 10 over 2 is 5. And that's also a counting. A whole. An integer. And it's going to be belonging to the rational. Right? This is a repeating decimal. The repeating decimal is a rational. Ta-da! That was easy. This is just a mess of a... Ooh. Okay, so 13. I would never... you're not gonna, I don't think you're going to see... Okay, so what are we buying? 3 Apple Watches. Oh my god. So this is made it into a mess. So feel free to use a calculator for this one. 462.84 times 3 equals, and again, 1388.52. A MacBook Pro 1, we're only buying 1, right? So it's 2434.84. 2 tickets to Australia, 1893.11 times 2. I think so this is 3786.22. So if we add this up, we get 8, 15, carry 1, 19, carry 1, 20, carry 2, 16, carry 1, we have a 7. Now, to find a tax on this, right, so it's going to be, I definitely would keep it as a decimal, so it's going to be, now your tax, I'm going to write it over here, is this, right, so we're going to change it to the rational number by moving to the left, so it's going to be 0, 1, 2, 0.08875. That's the format that you would use to multiply this times 7609.58. 609.58 times 0.08875. So your tax on this item would be $675.35. Which you would add to this total, right? So which you would add to this total. Am I asking you? Oh my god, what is the total after taxes? So we have to find that 7609.558 plus a tax, which is 675.35. 58 plus the tax of 675.35 equals, so the total with tax is 8,284.94. Right. Now, a credit card gives her 5 back, so the credit card says, okay, because you're using our credit card, we're going to give you 5% of that purchase back. But I don't think they're going to give you the purchase that includes the tax, so it's just going to be 5%, and I get 5% of her purchase. Don't worry too much about this. All right, more about the procedure here. So 0.05 times 7609. Right, so it's not fair for the credit card to give you back money on this because that includes taxes. The credit card will say, well, taxes is your problem. You're responsible for it. So that has nothing to do with that. But this, the part that you bought, I will give you 5% back of that. 0.05 times 7609.58 equals, so they actually, wow, you use a Discover card. Discover card is pretty popular with cashback. And they'll return $308.48 back to your account. So some credit cards have really nice, what they call benefits. And it's 8:15 a.m. So this is just a matter of. So I'm going to multiply, change that right away. 170 times 4 equals some number, 683 over 4. But that's the adult, and an infant weighs 1/8 of that. Right? So here's my of. Simplify? Of course not. I get this. So how many times? How many times can 32 go into that? I have no idea. 683 divided by 32 equals 20 times apparently. Which gives us 640. No, it shouldn't be 20 times. Here. 640 plus 32. Oof. Right, I'll just do it. 20. This is 360. Why am I missing 83? Comes down 2 times. I get 33. 20 times 3 is 60. 20 times 4 is 80. And 3 left over. So it's actually 34 times. Hang on a second, guys. I'm missing something. Because I'm dividing it by 20 and not 32. Sorry, it's 21 times. My apologies. So here's my mistake. I was dividing by, so it goes in 21 times, right? And you have 11 left over. 32. So your infant will be 21 and whatever, 1132 pounds. Pick format. You want to change it to decimal. You change it to 1.3 divided by is negative 0.45. I personally would do this. I think it's easier. You want to change both to decimals. Okay, 13 over 10 times 100 over 45. Negative. Stop doing that, please. Negative. So my answer is already a negative. Simplify, yes. This again, divided by 2 is 5, divided by 2 is 2. And I'm going to get negative 65 over 2. You can change that to mixed number, or look at multiple choice to determine what to do. Now this, I would change the decimal. So I actually get 8.2 minus 6.4. I'm actually going to just do this plus minus thing. I am just, well, I'll leave it like this. I like to see it as 2.1 minus 7.989. The same thing, right? Because the subtraction will change to addition. This, to me, is how I like to see it. So let's take care of these two. 8.2 minus 6.4 is going to be 1.6, 1.8, right? And then 1.8 minus 2.1. I'm taking care of this guy over here, right? So think about money. You have $1.80 and you spent 210. So now you're going to be at negative 0.3, which you're going to do negative 7.89. And 7.89, it's going to be a negative number. So if you're, again, more comfortable seeing it this way, you can change it. Right, so they're both negatives, adding, so we're going to get a negative answer. 7.89 plus 30 cents is what? 8.19. Okay. That's it. And again, you should be more than fine if you're comfortable with all these.